Hi, Year 3. Today we're going to be doing lesson 21, but this lesson will also help you with lesson 22 and 23, because this week we're going to be looking at how to subtract fractions, and then on Wednesday your task is a mixture of adding and subtracting fractions. So we'll have a little bit of a review right now, actually. So let's just look back at what we learned about last week. Last week we looked at adding fractions. So here you can see that I have a quarter plus another quarter. Now I've purposely shown you this one because this does not equal 2/8. And this is quite a frequent mistake that people make. People see 1 plus 1, they put 2, and then they put 4 plus 4, they put 8. They add both the numerator and the denominator. But hopefully you remembered from last week, I told you to add the numerators, but don't add the denominators. So here you can see that 1 plus 1 is 2. They remembered that. But then they've added the denominators. The reason why this is a mistake, well, let's look at this. You're saying that this is equal to 2/8, that a quarter plus a quarter is equal to 2/8. Now we've learned from our equivalent fractions that a 2/8 is actually equivalent to a quarter. So you can't say that a quarter plus a quarter is equal to a quarter. So we know that that's wrong. Let's look at what the answer should be. So we know that a quarter plus a quarter is not equal to 2/8. Let's do numerator first. So 1 plus 1, well, we know that would be 2 in the numerator, and then we don't add the denominator. So we keep the denominator the same. So it would be equal to 2 quarters. Now, we know that actually this can be simplified. We have an equivalent fraction here, which would be 1/2. Because 2 divided by 2 is equal to 1, and 4 divided by 2 is equal to 2. So we know that actually that should be 1/2. Hopefully you remember that. Now, let's look at subtraction. A very similar thing is going to be happening with subtraction. Here we have a whole that has been divided into 8. See, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. So the whole thing has been shared or divided into 8. That's why our denominator is 8. Now they're actually saying that 7/8, so that we have 7 of these 8s, and we want to take away 3 of these 8s. So here I've shaded those 7/8s. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. Now, the next step would be to unshade 3 of them. In this case, that's what I've done. You might want to use a different color, however you want. I've made sure to keep my 7/8 this blue color so I kind of remember. So I didn't include that 8/8. But now you can see I've had my 7/8. They're in blue. And now I've taken away 3/8. So I've erased 3 of them. How many 8s do we have left? 1/8, 2/8, 3/8, 4/8. So 4 in my numerator and 8 in my denominator. 4/8. We can see them. 1/8, 2/8, 3/8, 4/8. And what do we have here? Well, it's the same thing. 7 take away 3 is 4, and we keep the same denominator. So there we have it. So similar thing with addition to subtraction. You're only going to add or subtract the numerator because in this case, our denominators are the same. So here's another example of it. Our original equation, we had 8/9 take away 7/9. Now you can show it like this as well because this is saying the same thing. You only want to take away from the numerator. So 8 take away 7 is equal to 1, and we keep our denominator. This is an example from your work. So here you can see that our shape has been split or shared or divided into 9 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we've selected 7. You can see these 7 that have been shaded. Now they want you to take away 2 of these 9s. So that's why 2 of them out of the original 7 are a different color. And here we can actually put this as our part whole model. So take away 2 ninths. Now we need to figure this out and save things. So 7, take away 2. Hopefully you remember it. Use your fingers if you need to, but most of you are very good with your facts. So that is 5. Are we finished here? No, we need to still put our denominator, which they've put for us, 9. So we know that this is equal to 5 ninths. And you can easily check this using our inverse. We know that 5 ninths plus 2 ninths is equal to 5 plus 2, 7, and keep the same denominator, 7 ninths. All right, now this is another example that you might have this week. So here, just like you have repeated addition, this time we have repeated subtraction. Now, it might seem a bit scary that there's 3 fractions here, but I promise you it is not scary. You just need to do one at a time. So let's start with 11 twelfths, take away 3 twelfths. So I've written this down for you. So 11 twelfths, take away 3 twelfths. Now, same thing again, our denominator is going to stay the same. And we just need to think, what is 11 take away 3? Well, you can go back 1. So if I know going back 1 would be 10, then that leaves me with 2 left. So what 10 minus 2 would be 8. So that is 8 twelfths. We're not done. Oh, we need to take this 8 twelfths and take away 4 twelfths. So 8 take away 4 is 4, and over our same 12 parts. Now this problem, this activity, you have a butterfly and then you would need to try to match it. So this one I've colored green. You would then match it to the equation on the next page. So you would try to find 4 twelfths. Now it might be that it has been simplified into an equivalent fraction. So what number, what factor do both 4 and 12 have? Well, it could be 2. So it might be 4 divided by 2 is 2. 12 divided by 2 is 6. It might be 4. 4 divided by 4 is equal to 1. 12 divided by 4 is equal to 3. So you might see 4 twelfths, you might see 2 sixths, or you might see 1/3. So you would know that that matches with problem number 1. And you also today have a challenge pyramid. So this one, you need to use addition and subtraction. So here on our pyramid, we want to make the top number. So here you can see that we have 3 6. We need to add something to get to 4 6. So 3 6, something to 4 6. So I already know I'm going to put 6 as my denominator. Now what? 3 plus what is equal to 4? Well, you can do inverse. 4 take away 3 is 1. So we know that that's there. Now we can't do any of this side because we don't have any numbers. So let's start at 1. If you remember on our number lines that we did, this is saying the same as 6 over 6. That's our equivalent. So this time 6 take away 4. I'm going to do some mental maths here. 6 take away 4 is 2, and we're going to keep the same denominator. So we have 2 6. And now we can do this one. 2 6 take away 1 6. 2 take away 1 is 1, and we keep the same denominator. So that is how you would do the pyramid subtraction and addition problems. That's all I have for you today. Now remember, add or subtract the numerators, keep the same denominators. You don't want to make that mistake because we saw how that's actually might be saying that it's the same amount. So be very careful of that. Another thing, be very careful that you're reading your problem carefully. Is it asking for addition? Is it asking for subtraction? So today's work is just subtraction with pictures. Tomorrow is subtraction without visuals for you. And then Wednesday is a mixture of addition and subtraction. But I know that you're going to find this super duper and you're going to do an amazing job. So well done and see you later.